Hey everybody, Mr. Kowalczyk here. I know I'm not in class today, but I wanted to record a short video for you to get you started on some of these algebraic problems. I'm going to do a couple of each type, actually one of each type on the sheet that you got today from the sub. So I'm going to do number 2, number 7, number 22 down here, as well as on the back page. I'm going to do 27 and number 35. Okay. So I'm going to do those. That's kind of one from each of the different types, and they'll also be, my work will also be here on the answer key. So when you should see that on the back page. What I would like you to do and encourage you to do is to copy these down along with me during the video. So that way you can practice going through these problems instead of just looking at my notes on the answer sheet, okay? So here for the first one, we have a linear equation. We know it's linear because our variable is in the first degree, meaning there's no exponent or anything like that. And we don't have a square root. So we have b over 5 plus 7 equals 3. In this case, what I want to do is I want to get my variable b by itself. I'm solving for that. So here b is divided by 5. So the opposite of dividing by 5 is going to be multiplying. So I'm going to need to do that. I'm also going to get rid of this positive 7. Because this positive 7 is farther away from the b and it's another term, I'm going to subtract that 7 from both sides. Okay. Then I'm going to be left with, on the left-hand side, b over 5 equals 3 minus 7, which is going to give me a negative 4. Now, earlier I said that this is b divided by 5, so the opposite of dividing by 5 is multiplying. So I'm going to multiply both sides by 5, and that's going to give me b equaling negative 4 times 5 is going to give me a negative 20. And that's going to be my answer, so I put it in the box. Okay. Now with number 7, I have negative 130 equals 5 times the quantity, negative 5x plus 4. So what I need to do, and I see this 5 outside the parentheses, because it's not added or subtracted, I know it's multiplied, so that's going to mean I'm going to distribute this into both terms inside the parentheses. So my next line is going to be negative 130 equals 5 times negative 5 is a negative 25x, and then 5 times a positive 4 is plus 20. Now I'm going to combine my like terms. I want my variable on one side and my constants on the other. So I'm going to subtract 20 here. That's going to put me farther into the negative, so I go negative 150 equals negative 25x. Now I want to get rid of the negative 25, so I divide by negative 25 on both sides. Okay, and that's going to give me x is equal to 150 divided by 25. Negative over a negative gives me a positive, and that's going to be x equals 6. Okay. All right, let's take a look at number 23. 23 is a little bit more complicated. There are variables on both sides of the equal sign, and I've got like terms that I'm going to need to combine. So in this problem, there's also some order of operations that are important to focus on as well. First off, we're going to need to distribute this 8 into the parentheses like we did in the previous problem. 40 minus 2x equals 40x plus 40 plus 5x. All right, now I'm looking on the right side of my equal sign, and I have to combine my like terms, which are the 5x and the 40. And that's going to give me 40 minus 2x equals 45x plus 40. All right, so now what I want to do is I want to get my variables on one side and my constants on the other. I'm going to subtract 40 from this side. And that's going to give me a negative 2x equals 45x, because the 40's canceled out there. Now this looks a little strange, but let's keep going and see what happens when we combine our like terms. I'm going to add 2x to both sides. And this over here is going to become 0, equals 47x. Okay. So if we look at this and we divide by 47, 0 divided by 47 is still 0. So x is going to equal 0 in this case. So when you get a situation that looks a little bit strange like that, just keep combining your like terms and see if that ultimately will get you to a reasonable answer. 27, this is a proportion. A proportion are two fractions that are equal to each other. And last year you were taught, in order to solve these, what we can do is we can cross multiply the fractions in order to solve, get a new equation that's equal to itself. So here we have 9 times 9. So on one side of our equal sign, it's going to be 9 times 9. And that's going to be equal to 10 times x plus 8. Now be careful when you write this. If you write it like that, that's going to give you an incorrect answer because you're just going to multiply the 10 times the x. When you multiply this, you need to use that parentheses because you're multiplying 10 times this whole thing right here. Okay? 9 times 9 is 81, and that's going to equal, now I distribute, 10x plus 80. Combine my like terms to bring my constants over to the other side. 1 equals 10x, and then divide by 10. X equals 1/10. We could also write that as 1/10 like a decimal. Okay. So what you're seeing here in this one, this is the first time I want to point out to you, in today's work, don't expect all of your answers to be whole numbers. Okay. You can also check that out with the answer key up here. But I do want you to go through solving all of the problems, not just looking at the answer key. Last one, 35, is going to be some square root problems. So with this one, excuse me, we have our first exponent. So this is a nonlinear. It's going to be a quadratic because this is a squared exponent. We have a squared plus 9 equals 12. And now in all of these problems that we're going to be doing today with our exponents, as you probably have seen, or maybe not, in the section heading, it says solve each equation by taking square roots. So for this, you're going to need a calculator. And I'll show you how to use your calculator in order to solve for the number. So we're going to get a by itself again, and we subtract 9 from both sides. Then we're going to get a squared equals 3. Now, how do you find a by itself? Well, if you remember, the opposite of squaring something is taking the square root. So the next step would be to square root both sides and the square root of 3. Okay, so the square root of a squared is just going to give us a, and that's going to equal the square root of 3. Now, you can leave it as the square root of 3 if you want to, or you can also say, get your calculator out, and let me zoom out a little bit here so you can see kind of what buttons I'm pressing. So in most calculators, they'll have similar buttons, right? So in this situation, what we're looking for is the square root symbol, which is right there. And on my calculator, you can see that it's light blue right there. So then what you're going to do is, in order to get to that light blue button, you're going to press second, which is also light blue. And then you press the square root button right there. So it gives you square root, and then you type in the 3 inside of that, and then just hit enter, and it will tell you that the square root of 3 is approximately 1.7. So if you're going to do that, then what you would say is approximately, which are our squiggly equal sign, 1.7. So either of these answers would be okay if you wrote a is the square root of 3 or a is approximately 1.7. So you could put either of those down for your answer and get the correct one. All right, y'all, please finish up all of these problems today. I'd like you to do your best to get through 1 through 40. And then just know that if you finish those, then you don't have any homework. Otherwise, you're going to need to finish those, and I'll check them over on Tuesday. All right, have a good weekend, be safe, and I will catch up with you next time in class.